No, testing. Okay, so shall we start? Okay, let's start. Start. So how you guys prepared? Have you do revision yet? Not yet. Please do and one more week to go. And then please prepare while you're doing. Prepare your cheat sheet. Yeah, cheat sheet. Whatever you need, the formula test, please bring it in to the exam. Next Thursday. Yeah. Okay. I also put the practice exam question. You guys see see in the resource fund. Yeah. So don't just look at the answer. You won't understand. I mean, you won't remember. Okay. So try and do. Try and do. Okay. Yeah. Try and do. About the calculus one project one. Okay. So project one, there's only 1 month left. Okay. So you can start thinking about it already. Okay. Some of you already kind of approached me. And then, so how you write, you need your introduction. Okay, you need your body. Okay, body need to include the definition, proof. Okay, of your statement, and then example. Okay, how we going to use the theory? Okay, example. How we apply it. Okay, you need to write. So 3 parts. Yeah. Yeah. So what's included in the midterm? So it will be up to chapter 10. Okay, we'll finish up the polar stuff, and then up to that, that's all. Okay, and then after chapter 10, we'll start partial derivative. Partial derivative, yes. Yeah, up to chapter 10 only. Okay, so series, Fourier series, and polar curve. Hey, I'm talking now. Series, Fourier series, and then polar curve. How to polar curve? Yeah. And then the special topic for a series. For a series. Definitely got for a series. The pattern is similar to the practice exam question. Okay. Yeah. Similar. No, not like that. I mean the pattern. Okay. Yeah. Yeah. So all the skill inside you need to know. Okay, you need to learn. All the skill used in the exam you need to learn. Question? Any question? Okay. Please be prepared. Okay. Okay, I wait for your full scope. Okay. Yeah, please be prepared. Definitely you need to do the tutorial question. Okay. Get used. Because I got my previous student keep telling me I think I know, just that I cannot write it down. Then I will say, you don't know. Okay, actually you don't know. Okay. I mean it's natural. It's natural that you think that you know, but actually you don't know. This problem actually follow me until I'm PhD. I also feel that. So it's natural. So please change, refresh your knowledge. Okay. Refresh your knowledge. Okay, and last time we stopped at the polar curve, right? Anyone try the polar stuff or not? Change to XY coordinate. No one sent me so far. Yeah. If you have tried, you can let me know. Actually, there are 3 ways. My students show me 3 ways. And these are all from AIT one. Yeah. AIT student. Yeah, that's why I like their class, because their class like to adventure. So last time we talked about this question, right? Okay, we want to find the area of this polar curve. But there are two ways to do actually. So one way I told you to change these to XY coordinate, right? So change this to SY coordinate. The other way is to use parametric parameterized curve. Okay? You can also use parameterized curve to describe the circle here. Okay. So if you change to XY function, you need to deal with this kind of equation. Okay. And then try to integrate. So there are top and bottom, you need to decide which one to pick. Like a circle, you need to pick top, upper hemisphere or lower hemisphere. Okay. And then the other one is changed to the parameterized equation here. Okay. You describe y and x using one variable. And then you integrate as well. Right? Okay. Okay, you can do it. Actually, I posted it out already. If you don't want to do, you can read what they write. Okay, you can read. And then they all compute to the same answer. Same answer. Yeah. Okay. These are on the notes already. You can check. Okay, how about we just test what we're gonna do, what you need to do to find an area. So let's say we want to find this area here, okay, of a 4 leaf. So what should you do? So how to find the area of this leaf? Where's the angle from? You know? From which angle to which angle? This leaf here, cover from what angle to what angle? Yeah, bro. Over 4 to negative pi over 4. Okay. So you will integrate this function from minus pi over 4 to pi over 4. Okay. And then you do the integration. Make sense? Okay. How about this one? So there are two polar curve here. Okay, one is r equals to 1 plus sine theta. And then the other is r equal to sine theta. 3 sine theta. So in the exam, right, I will ask you to do sketch and find, like your assignment. Okay, so you need to sketch yourself, and then you need to find it out. The area. Okay, I won't give you this picture here. Okay. So you need to learn how to turn a polar graph from r theta plane to xy plane. Okay, you need to know that. Okay, how to draw a r theta first. So, for example, you need to know how to draw 1 plus sine theta on r theta curve. So it is something like this. So theta 1 plus sine theta is this. Right? Okay. So how to turn this into a polar graph? You need to know. Remember last time we changed point by point and then see whether the radius is increasing or decreasing. Okay. Okay, you must know this. And then let's say you want to find the region bounded by these two. Okay, so it's this shaded region here. So how do you find this? From this picture here. So let's say I didn't give you this picture, right? Okay. Do you know how to find the intersection? You just equate the two sides. Okay? Equate the equation and then find the theta. Okay. So after you found this intersection point, so what should you do? What should you do? How to find? Huh? Sorry? Yeah? Integrate. Right, integrate from where to where? pi over 6 to 5 pi over 6. Okay. Then, so you integrate on both polar curve or what? Both. And then minus. So who minus who? 3 sine theta minus 1 plus sine theta. Why? Because when you integrate over sine 3 sine pi, what are you integrating? You are integrating this, the whole, looks like a fan here, right? This whole fan here. But you want to throw away the inner area here. But this inner area here is realized by 1 plus sine theta. So you just need to take away this part. Okay. So remember, maybe there's one point I didn't point to you last time. So if you integrate a curve with respect to polar, right? Which area are you integrating? You are integrating the area that has a ray going to the origin. Okay, this is the part you are integrating. Okay, so what's the difference if you do the normal xy integration? Okay, the normal xy integration should give you the vertical area here. Okay, so this is the two different things. Okay, so please don't do wrong. Okay, if you do polar integration, the green part is what you integrate. If you do xy integration, the green part is what you integrate with the same curve here. Okay, so you need to remember how to remember. When you do polar integration, what you get is like a pizza. Okay, it's a pizza. So you have to go back to origins. Okay, so this is the difference between these two. Okay. Okay, Ethan. You get it? Sure. Okay. Yeah. You cannot just talk about x value or angle value. You should talk about what function you are looking at. What function you are looking at. Okay. Because what we are looking at here is a polar curve. It's a polar curve. Okay, it's a polar curve. Okay, because the coordinate we give here is all in circle. Okay. That's why when you integrate this point, actually you integrate along this ray here. Okay. Similarly, like last time, I can say this, I can integrate, I can replace this with xy point. Okay, if I do xy point, then this function will change. Okay, if this function change, I integrate with xy coordinate, then I will get the rectangular area here. Okay, so depend on what function you're looking at. You are looking at the polar curves or you're looking at the normal xy curve. Okay, it is because of the choice of coordinate we make. The choice of coordinate we make. Okay. 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 It's because of the choice of coordinate we make. Remember the xy is the rectangular coordinate, but polar coordinate is the circle one. Okay. Make sense or not? Okay. So since we are looking at points in circle, right? When you ask about integrating from one angle to the other angle, so you are looking at all the radius, all the point of this angle along the radius. Okay, one way to think about it is like this. So let's call this R, right? R d theta, right? You can imagine this R is actually R minus 0. Okay, where is 0? 0 is here in the origin. So you take the area here minus this point. Here now. Okay, so you integrate up to this area, this radius here. I integrate along the angle up to the radius R here. Makes sense. I integrate from theta 1. Okay, so here is theta 1. I integrate from theta 1 to theta 2 along the radius until where? Until the function r. So I stop here. Okay, so that's why I get something like the pizza here. Does it make sense? Any question or not? Any question? It depends on the coordinate. Please remember, depend on the coordinate we pick. Polar coordinate is telling us the point is at which circle. Okay, which circle? Circle of radius what? Okay, at what angle the point at? Okay. Okay. Please bring this concept to do your question. Okay, when you do the question, think about this. Okay, when you do the question, think about this. Why am I finding this the pizza area? Okay, think about it. Think about it. Okay, so the key point is polar coordinate tell us the point is at which circle. Okay, circle of radius one. Okay. Yeah. Okay. Okay. So, any question or not? This is from the last lecture. Any question? So you must ask question for my class because as I explained to the other class, so in my lectures there are two parts. There are two parts. So one part I tell you what to do. Okay, the other part you have to do it. Okay, because I don't believe that if I just ask you do, then you do, you will get anything out of it. Because you will just forget easily. Okay, so one part is you have to do. You have to have your own understanding. You get my understanding and then compare to your own understanding. Okay, so you really need to understand with your own understanding. So how to do that? You need to really hands-on, right? Calculate. Okay. So in my lecture, there are really two parts. You need to put your effort into. Okay. Of course, when you do it right, you will meet a lot of problems. Okay. If you have problem, you have to ask me. Okay. So I can speed out your learning process. Yeah. Okay. I'll speed out your learning process. Okay. So let's continue. So next part. Okay. Okay, next part, we will keep talking about the same thing. Okay, what's the same thing? Last time we talked about arc length of a curve. Okay? Arc length of a curve. Okay, so we also talk about arc length of a polar curve. Okay, so given the polar curve, okay, so what's the length of the polar curve? So given polar curve, okay, so we have to have a finite interval here. Okay, given this, okay, so what's the length? What's the length of the curve? Okay. So what's the length of the curve? So let's call this length L. Okay, our polar curve is R. Okay, so what's L? Okay, so what's L here? So what's L? Okay, so what's the thing we should put here? Maybe we start with what we know. Okay, we can start with what we know. So what do we know? So we can turn our polar curve, okay, into some xy curve. Okay, some curve in xy. Okay, so we turn our polar curve into xy curve here. Okay, if I can express my curve in xy form, okay, so how should I compute this length here? Okay, let's say our xy is in terms of t. Yeah, in terms of t. So how should I put this? So I think we should write it as xt and yt, and then with some interval c to d. Okay, so we turn it into a parameterized curve. Okay, we make it into a parameterized curve. Okay, s and t. So what's the formula of this? Remember, we want to calculate a length. We can use Pythagoras theorem. Okay, so we need to use the upgrade version of Pythagoras theorem. Okay, taking some limit. Okay, which means we take the integral. The integral of square root of dx over dt squared plus dy over dt squared dt. Okay, this is what we know. But this is a rectangular coordinate. Okay, so how to turn into polar coordinate? What's the formula between polar coordinate and rectangular coordinate? How you turn xy into r and theta? X equals to r cosine theta, and y equals to r sine theta. Okay, good. But remember that we are looking at polar graph, right? So this means the point on our curve, the radius is depend on theta. Okay, our radius is depend on theta. So last time we have do this differentiation, right? Using product rule. Okay, using product rule. So we'll get something looks a bit tedious. So dx over dt is minus sine r sine theta plus dr over d theta cos theta squared plus r cos theta plus dr over d theta sine theta squared. Okay, so at first sight, you see there's so many terms. Okay, I want to square it. I want to square root it again. Okay, so can we simplify this or not? Okay, I made you try. Okay, you try. You try. Try and compute this. Can you simplify this? You try. Let's try. Everyone sleep already. Try. Calculate this. Yeah, work it out. Yeah, work this out. Asking after you calculate, let me know what's the answer. Calculate this. So become theta already. I need to change back. Got it? Got it? Yeah. What did you have? What do you have? Mm. Mm? Yeah. Mm-hmm. Mm-hmm. Ask you again. Okay. Okay. Yeah. Any more? Uh, Alice? Okay. You get that's all. How about the rest? How about the others? Got different answer. Answer you get. What the answer? What more? Marian. Yeah. Okay. Yeah. Okay. Yeah. Okay. Okay. That's all. That's all. Others agree? Okay. Yeah. So this is what you should get. And then can we simplify more? No? Okay. So we can combine the sine square and cos square. Okay, to 1. So we got r square plus dr over d theta square. D theta. Okay. So note that when I do the change of variable, right, I change it back to AB. Okay. And then I think you should ask what is CD. Okay, so please find what is CD. What should CD be? I will write it in my note later. Okay, please find what should CD be. Yeah, please find it. What should the CD be? So after change of variable, we change it back to the domain we want. Okay, A over B. So what are you integrate over? You integrate over square root of r squared plus the rate of change of radius depending on theta. Okay, so this is the formula for arc length of polar curve. So square root of r squared plus dr over d theta squared. Okay, so you can see that. Do you appreciate or not? Do you appreciate this or not? Do you appreciate how these terms get cancelled? Do you appreciate this or not? Do you appreciate why there are so many terms here when you expand and then they cancel into this 2 terms left? Do you appreciate or not? No. I mean, this is the reason why I do maths, basically. Because maths simplify a lot of things. Okay. Real maths is simple. Yeah. I mean, I very appreciate this kind of we call it symmetry. Okay, why I call it symmetry? Because you have something cancelling with each other here. Okay, if they don't cancel, what can you imagine? They are like 2 times 2, 4 terms, 4 terms plus 4 terms, 8 terms, and then you want to take square root of them. It's a disaster, you know. You want to take square root, and then you have to take square root of 8 terms. Okay. So in the end, what is important is r and the derivative of dr over dt. Okay. Yeah. Okay. I hope you will appreciate these maths. Otherwise, when you calculate, you will cry. You keep seeing this, you will cry. You know. Okay. Okay. Let's do an example. Okay. Let's check example. We want to test this example again, right? So let's test on example r equals to 2 cos theta. Okay. Remember this curve or not? I'm not sure you remember or not. This is the very first curve that we plot last time. R cos theta from 0 to pi. Okay, this is the very first curve we plot last time. And so this is a unique circle center at 1, 0. Okay. So unique circle center at 1, 0.
Okay. So let's say we want to compute this length here. Do you have a guess what's the length of this circle? 2 pi. Okay. So we should expect this formula give us 2 pi. Okay. So we're integrating from 0 to pi, okay, of square root of r squared, which is 4 cos square theta. dr over d theta is what? 2 minus 2 sine theta. Okay, minus 2 sine theta squared is just 4 sine square theta. Okay. So you see, again, trigo identity pops up again. Right. Cos square plus sine square is 1. Okay, so you get square root 4 d theta, which is just integrating 2. Okay, from 0 to pi. And then this is becoming 2 pi evaluated from 0 to pi, which is just 2 pi. Okay,
So you see, the integration domain here with p is pi. Okay, so from 0 to pi is enough to plot a whole circle. Okay, if I integrate to 2 pi, what happened? I go another round. Okay, I go another round. So meaning I will get 4 pi because you go 2 times. Okay.
Okay, easy or not? Too easy, yeah. Okay, good. I like you. I like it. Okay. Yeah. So basically, there's one example on cardio you can try.
Yeah, this is basically for chapter 10. We will finish here. Any question on chapter 10? We'll finish here. Later we'll go to interesting stuff. Partial derivative. Any question on this?
There's not a single case for
You will get a negative if you go. So now we are integrating from clockwise, anti-clockwise direction. So I think if you do clockwise, then you get negative. Is it true? You see. Yes. So positive and negative, okay, when you get the area right, positive or negative depend on the orientation you have. Okay, you depend on the orientation you have. Okay. But the hardest part of this orientation, right, is when the area will cancel. So within a curve, you might get the area cancelling each other. Then it will tell you something wrong there. Because you trace out some area, but they are in different direction. So they cancel out. Yeah. But in our course here, right, we won't give this kind of condition. We won't say suddenly when you integrate, you have positive and negative appear together. Okay. I mean, you can always reduce to a case where the direction is positive. Okay. So the moral of the story is whenever you see negative area, you are going in a different orientation. That's all. Okay. You are in a different orientation. If you have negative area, you are going in different orientation. Does it make sense? Okay, very good, very good. You are ready to be a mathematician already. Right? So if you don't understand a word, you should ask about the definition. So what's orientation? Okay, orientation is in Chinese it's called 方向. Okay, 方向. So let me show you some 方向, right? So in a line, okay, there are two orientation. Right? You can either go to the right or you go to the left.
Okay, so there are two orientation in a line, either left or right. Two orientation. Okay. How about on a 2D plane? Orientation on a 2D plane. Okay, I'll do. You can go clockwise or you can go anti-clockwise. Okay, this is the orientation. Have you ever asked or not? Have you ever asked the question, why we draw X like this first, and then we draw Y like this? Okay, why not we draw X like this and Y like this? Go down cannot me? Why I cannot start with Y and draw X? Why? Have you asked or not? You asked about this question. Why X have to go to the right or have to go to the right? Why X cannot go to the left? I just now say got two orientation, right? Why? Sure. I cannot go positive on the left. Can I go positive on the left?
At the right, but at the left is bigger.
Did we say that? Did we say that?
I'm not sure about that, but at the left, I think it's already set right.
Don't know.
就我们从之前的
I know.
来讲，
Yeah, I mean, of course. I mean, 什么叫之前的教育？之前的教育就是从现在的教育开始，大众教育就是从现在开始。What did you say?
是我一方的吧？
哦，幸好你不是那个开头而已。Okay, it's okay. Joking only. Okay, joking. So I mean, of course, this is very depending on the first person that said this. Okay. So what have you learned in the primary school, whatever, is set by what we do now. Okay, what we do now. Okay, what is the most practical one? Okay, we set. Because we want all the students to learn this calculation first, so that I can teach next knowledge. Okay, do all these calculation already, then you can calculate more difficult stuff. Okay, so I always say to my class, okay, now you are taking a mathematics degree. Okay, you have to set the rules. So how to set the rules? You need to set a practical rules. 能够用的、实用的 ，OK， 不要做一些没有用的 rules，OK 吗 ？OK， so it is based on practicality. Okay, so what's the difference here? Why I add here? Okay, so first I do X like this, and then why I add my Y like this? Because there's a convention I'm following. I'm following the anti-clockwise convention. So it's like go up. That's why it go up. Okay or not? Okay. Okay, so this is the anti-clockwise here. Okay, can you see anti-clockwise here? Oh, here is the anti-clockwise. Okay, so this is the anti-clockwise. So I let you guess. Okay, I let you guess. So in 3D, how should I draw? Let's say I got my X here. I got my Y here. Where is my Z? Like this Pandai here. Up. Why is it up? Why is it up? Anti-clockwise, who say? You say anti-clockwise. Why anti-clockwise? Where did you see anti-clockwise here? Where did you see anti-clockwise here? How is it anti-clockwise? Why cannot go down? Okay, first of all, it's straight because this is the one that's 90 degrees to both of them. Okay, you can see that this Z here, right? If you this Z is a linear combination of X and Y. Okay, I just said this. Okay, that this line here is a linear combination of X and Y. So this is a 90 degrees to both.
Okay, so I think I should draw something like this.
Why is this a 90? Where's the anti-clockwise? So if you try and do this X and Y anti-clockwise, right? Okay, so this extra axis here will follow the right hand grip rule. Will follow the right hand grip rule. Yeah, so if you go from X to Y, and then this one will go up. Okay, yeah. Okay, so whenever you add in the axis, you add in with orientation, which is a anti-clockwise orientation. Okay. Yeah. Yeah. So this is the orientation.
Okay, so I mean, for now we live in 2D and 1D. Okay, so in 2D, 1D, this is what you need.
Okay, when vector calculus will go to 3D. 3 dimension. Okay. Hey, you live in 3D, eh? You live in 3D, eh? Right. Huh? What? Like what? SB? What is SB?
Okay.
Wasabi. Okay. Any question other than this orientation? Okay. Simple or not? Okay. Exam cannot cry.
Okay.
Please be prepared. Please be prepared. We still meeting 2 more times. Okay. So make sure you bring question. Okay. Whenever you question, bring to lecture. Okay. We can settle it before exam. Okay. We do it together. Okay. Okay. Yeah. Bring to the lecture. Okay. We have 2 more lecture before the exam. Okay. Or you want to listen what's the experience for your senior? Okay. You want to You guys want to hear or not? Experience. Midterm experience. Right.
What is
Ah.
as you say conceptually hard lah.
Conceptually. Yeah.
So bring calculator also no use.
Mm. Mm. I think calculator will help you calculate. Because it's an unusual, probably it's an unusual exam for you guys. Okay. That's what I experienced when I first having tests in my uni, implementing tests. Yeah. Maybe you'll get the same feeling. I'm not sure. Or maybe you're good. Maybe you're good. Okay. Okay. Please be prepared. Still got 2 more times. Okay. Got chance. Ask. Please ask. Very hard concept question. Throw it up. Then we will settle together. Bye. Take a break.
Okay, let's take a break until 4:07. Okay.
是说，他是做关于的题目的，然后一些东西。
如果这样去大为，
更进来一种。来，这样做。
好玩的非常无聊啊。
熬夜。
平常很熟练，你一定要分出谁？而且
我可以听到同样的是的，就是玩他讲话，因为他讲话嘛，也另外一个朋友。
哦，不用还深，哎，考试他刚才要考重点的时候就这样。
但说是可以多一点那种，跟什么 background，那种买那种线高的。要到什么来说？差不多。
我买个10块，对，他选是复合，我忘记。
他们我说过，那有的是。啊对，然后 body 就要介绍所有用到的，比如说几月几用到，我也会，我是那种。
干嘛？那个
给人家的
管理的人啊，你好，
很少，很久没有。
超
一个空因为我有的才在练手嘛。
所以他才这样，对的大。
就compare 他那两个算是东西跟他给的那个他解释为什么取的，然后你就解释他为什么他不是这样的。我说的那个区别呢，有些网友就讲出来之后，based on 他是还有什么？他们出的时候就必须，就解释，就解释为什么那个人有非常说是都是这样。
那讲。我跟你妈，你说，
我很惊啊！
有啊，有什么？非洲，我还不知道我要什么回味，有什么好的意见？
有啊，我觉得。
好啊，薄荷很难吃，
还一起吃呢。
难吃。
很像最近，他叫丁丁，他就是来小岁了。
长大难吃。
不是还是好吃的，他觉得不好吃了，薄荷冰冰。
奇怪，我觉得 是哦，没有，
跟在那个
我也是不
哦，
认识。
还有对你说的，
啊，才刚我在我面前做。
今天要写完。对，不要担心，好看还有好多的东西。
好了。哎，你们认识一位人叫邱成通吗？邱成通认识吗？认识谁是邱成通吗？啊，就一个很伟大的数学家啊，不是就是你跟他吃饭，在梦里是不是？谁？一头牛啊，吹牛来着吗？他在，还在。他之前是那个哈佛的系主任，哈佛的太阳北方人。现在他退休了，然后他在清华，对清华，他会去清华训练中国人。给你看一下他讲了什么东西。等一下，等一下啊。
所有学问的成长、学问的提升，相应的一些学科竞赛。学科竞赛跟考试都有问题，我自己也听过这个途径，但是刷题、机械式的分训练是不好的，不鼓励小孩子思考。所有学问的成长、学问的提升，一定有思考。现在这种刷题就是这样，学一定技巧，是有老师一定的技巧。完全不给学生一个空间思考问题，用不同的方法来解决问题，这是很不幸的事情。不光是中国人这么说，新闻报道当中你也可以看到，小时候就已经去到美国的国外的人，他在说
他要不要刷题 ？OK， 不是说你不可以做题目，但不要刷，不要拿来刷。OK， 不要刷，要想。做题的时候要想。OK。做题的时候要想 ，OK， 思考 ，OK， 不要算吧，要思考。OK， 还有一个东西就是你看到哇，这个人很厉害啊，什么都不是的。OK， 你也不要看到我很厉害，我不厉害，所以我就叫你们，也叫我名字就可以，我也不用叫我老师的，你可以尊敬我 ，it's OK。我想讲的就是，每个人都是一样 ，OK， 我也会犯错，圣人都会犯错。来，让你看一下这个第三个。
是好了演讲，就听到创造了这个学问，在你面前讲出来，你感觉是不一样的。你看有些学问，看见好像是因为很困难，最伟大的人才做得出来。但是当这个最伟大的人在你面前讲的时候，发觉他就是普通一个人，他讲的话也会有错，走的路也是容易走错路。但是就在我面前，他能够这个讲出来，我梦寐以求的数学讲的头头是道，我的感觉一定学能进入。其实一个很重要的事情是，就算是最伟大的学者去听课，听得懂的可能只有20%、30%。很多时听课 只听到10%，所以你就不是有益。
您希望未来在他们当中培养出什么样的数学大师？
其实不一定大师，只要有真正的空间就行了。因为大的问题啊，要几十个人一起来做，那其中的小部你有贡献的话，现在很多学者他写很多文章，也做很多不同的问题，也很复杂，同时文章内容也很长，50页纸、100页纸都有，但是得出来贡献可能是无关痛痒的。我们希望90岁的学生做一些重要的问题，就算不解决它。
你看，正常的，如果你在一个班上听是很不要睡就可以了。OK，yeah， 正常，很正常，都是这样的，这是常态。OK，
对
，and then 还有讲到什么 point？ 对，解决这个问题，对，他这个 about 这个 point 是要很多人解决一个问题，为什么？因为现在我们要解决问题是各种不一样背景人的思考进来的 knowledge 混在一起，所以为什么这个人会想到这样？为什么他会往这个方向走？很大可能和他的背景有关系，和成长背景有关系，他普遍的环境都有关系。OK， 你不能够像以前这样，以前可能就一个人在做吧，他要怎么跑就是他怎么跑嘛，可能高想怎样跑他就怎样跑，所以他跑了一大堆路出来。OK， 或者牛顿想怎样跑就怎样跑哦。其实牛顿那时候 ，during Newton times they already have some meeting 什么意思？就是他其实有跟 Leibniz 他们一起 meet 的嘛，他们肯定有 seminar 啊什么啊，会遇到会聊这些题目的吗？后来才会出现到，怎么牛顿又发明 calculus 还是 Leibniz 发明 calculus？ 大家差不多一个时间想出来的东西，都是大家一起讨论的成果。OK。No one. No problem. No problem. just now 没有听到啊，真可惜了。但是有放在我的 YouTube 啊，可以去看。我的 YouTube。OK， 看这个 counter example。So counter example 非常重要。I want to remind you, especially in my exam, you need to know how to create counter example. Counter example very important. 然后来看一下这个 counter example 有多难。
证明，包括他本人。
这是个很困难的事情，因为当时我们构造人生空间的时候，没有任何的例子表示它可能对的。在数学上呢，讲什么东西不对，就是找反例。所以我们就花了差不多3年功夫找反例。我以为我找到了反例，但是2个月以后，克拉米先生写封信给我，他讲可能是我没有理解清楚你的想法，你可不可以给我解释一下？当时我一看，我就觉得有问题，所以我花了2个礼拜，基本上不睡觉，天天不停的想办法弥补出现漏洞的地方。可是每次在最微妙的地方就不行了。我回了他信，我讲我当时的这个做法是错的，也因为经过这2个礼拜的很痛苦的思考，我晓得我以前这3年来的想法不错误的，所以最后我掉过头来去想证明它是对的。
那个过程艰苦吗？
我就花了3年，从73年一直到76年，每天工作超过12个小时，整天在算。我的老师曾经跟我讲，怎么样子分别一个数学家有能力，就是他起床第一件事他想出的东西。当时我身上起来就想这个问题，
当您在证明了卡拉比猜想之后，您用了一句很浪漫的宋词来形容整个过程。
我想罗发法言独立为语言相费，因为
要看可以继续看回家。But what I would say is, you see, you want to prove something is not, or a statement is not right, provide a counter example. Okay, you need to be able to construct counter example. 落发人独立，
这还是倾向吗？
讲数学咯，讲数学。他睡觉还在想，做梦也是在算。哦，Yeah。OK，不然再看最后一个，我要鼓励一些英文差的人。对，我要鼓励你，我要鼓励你。哎，我要鼓励你啊！哎，我要鼓励你，来，这个人的英文一开始不好，大概听他讲什么。可以。
So, by the way, how's your English?
very bad,
Very bad.
still not good.
So this is not a problem either, and maybe because mathematics is its own language.
Well, the first of all, do not need me to teach, so that helps a lot. I have a strong accent, and so when I taught students, may not be used to it at the
Right.
beginning, but later they become more used to
But
it.
in terms
Learning is never any problem for me because in high school we use textbooks which are English.
Awesome. Okay.
We can read, we can.
This is the advantage of Hong Kong,
Yeah.
that there is English in the
Yeah.
world.
Don't use Thai school.
So I told you before that in a way, this is the story of your curiosity.
Right.
So you've gotten to Berkeley. It still seems a miracle to talk about it, but there you are in Berkeley. You're in the mathematics department from the beginning, probably.
Right.
How are problems chosen for you?
他英文不好，他还是去美国读书吧。你英文不好，还是来 SMU 读英文，是不是？OK，所以
那我们英文不好，然后你就会看英文的东西，这样子吧。
没有办法啊，这个是英文，所以我没有办法。OK，
教华语教。
Yeah，so 华语也不会。OK， 还有一个班，他讲 pure max 很重要，来听一下。如果你不要就不要了，但是听一下为什么人家讲 pure max 很重要。
How are problems chosen for you? Which direction in mathematics begins to be important?
Oh, well, it's interesting because when I was in Hong Kong, I read many books, but I was not guided correctly, I think. And the library is very poor.
他英文不好，我也听不懂他在讲什么。
I have the idea that the mathematics which cover more abstract things are
Pure mathematics.
pure mathematics, and the more pure. And I was under the impression functional analysis is probably the best subject in the whole mathematical.
This you came to by yourself.
Yeah.
Yes.
And so I always thought that that's my future. Then I came to Berkeley, and I started to know that many subjects are never. And I literally study from morning at 8 a.m. all the way to 5 p.m. non-stop, because I have the many subjects I've never learned before. I want to learn it.
Yes.
So I even eat lunch during class. After the first quarter, this is a quarter system, I decided that functional analysis is nice and good, but it's not the subject. So I started to see the beauty of geometry, Yeah,
Yes.
right. So I started from it. In fact, see, I came to Berkeley in 1969 in fall, September, in September 1st. And there are many things I do not know about America, but I start to be more used to it. December that year,
差不多。
there was Christmas time.
他讲一个东西 ，the pure the better。pure the better。他讲什么？他讲，因为 pure abstract you can apply in many places. Yeah.
I'm a pure idiot.
Yeah, idiot. Yeah. Okay. And you can just now you go listen how long is study, right? 8 a.m. to 5 p.m. Okay, good. Good. 啊，对对对对对。看地方啊。Okay. Okay 啊。Yeah.
Was in Berkeley. I had a very good course.
So you see, just now you say beauty, right? Beauty of maths. So if you cannot see the beauty of maths, you'll definitely feel tired. Okay. Yeah. So you have to be able to see the beauty. Beauty is in the eyes of beholder. Right? Beauty is in the eye of a beholder. 这什么意思？不是啊，情人眼里出西施。Of what? Eyes of what? 什么讲
Beauty is in the eyes of this.
？Eyes of me 是什么意思？
Beauty and the beast.
哦。
哦。呀，不要进来哦。
Oh, okay. Yeah. Okay. I think 感觉啦，给我感觉啊，你们班应该会很好吧？就继续努力啊。OK。我还没有来真正 test 到。啊？I mean 我只改过第一份 assignment， 我还要看第二份 assignment， 就看你们整个 assessment 怎么变化，怎么进步。OK。没有啊，我没有这样说啊，就是说，我会看每个 assessment 我给的，看你们怎么变化。OK 吗 ？Put effort 啊 ，must put effort。我很讨厌懒惰的人啊，很讨厌，真的很讨厌。I mean, everyone have their own weakness, right? But you need to face it. Some of them just try and run away. You need to face it. Okay, please face it. Okay, yeah, please face your weakness. Okay, we should start new stuff. Okay, let's start new stuff. Yes, chapter 14. Okay, we're gonna do new stuff. Okay, what kind of object you have seen up to now? Function, series. Series are defined from where to where? Series are defined from where to where? Oh, okay. Natural number is sequence actually. So let's start with sequence. Okay, so sequence is from where to where?
What?
No, what's the domain? Natural number to real. Okay, so natural to real number. And then we learn series. What is series? Real to real. Good. Okay, real to real. I don't know. Real to real. Right? Okay. And then we made Fourier series as well. So inside series we have Fourier series. Hey, about Fourier series, I forget ask you guys one thing. Do you know why, for example, trumpet and flute? Any one of you are in band before or not? Any band? Music, huh? Do you play music? Do you guys play music or not? Or listen to music at least? Yeah.
Yes.
So flute and trumpet sound differently, right? Yeah. Okay, why they sound differently? Hey. Ah. Wavelength, okay. So how you realize the wavelength? Actually? So sound wave is a periodic wave. Right? So periodic wave you can do what? Fourier series. Okay? If you do Fourier series, what do you get? You get the Fourier coefficient. You integrate the function multiply with cos of sine to get the Fourier coefficient. Right? So why flute and brass trumpet sound differently? Because their Fourier coefficient is different. Okay. So their Fourier coefficient is different. We feel a different sound. Right. Because Fourier series help you to break the sound into bases. Combination of bases. Okay, series. And then next. What's the next? The parametric equation or polar curve or so on. Parametric curve. What do we do here? Function from where to where? From where to where? From R to yes, R squared. Okay. Why R? Remember the time variable we put in. Time that control the ST and YT. Right? XT and YT. So T gets sent to XT and YT. Okay. So what are we doing here? We have a line. Okay. We want to see how this line sit inside R2. Okay. We put line inside R2. For example. Okay. We'll put a real line into R2 and then see how it looks like. Okay. So this is parametric curve. So now we will do a different things. Okay. We swap the domain and codomain. Okay. So we will look at function like, so we'll look at function real value function of two variables. Two variables. So meaning now my function is going from R squared to R. Okay. So how should you imagine this? So you should imagine that on every point in R squared, okay, the xy plane, I have a value attached on each point, for example, like this. Yeah, I have a number attached on every point. Okay. So can you imagine of one object like that? You have a plane, okay, and each point carry a different number. Can you imagine something like that? What? Why?
Shape body, one shape body.
Understand? What's that? Understand. Better shape, I don't know. Game or what?
It's a board game.
Oh, it's a board
You
game.
guess the coordinate, and then and then you shoot the missile, and then if there's a ship over there, and then there's a ship.
Oh, okay. I didn't play before. Okay. So the point represent what? Better ship.
Body of the ship.
So whether there's a ship on that coordinate or not. Okay, sure. How about a real life thingy? So what's the question? So anything you can think of such that on the plane you can attach a number on it.
can the number represent anything? So sure. Yes, height. Okay, Matt. You have a height of your cube, right? You have some control, right? So you have a map like you have a control like this. Okay, increase in height. Okay, so maybe the number tells you about how high is the point. Okay, how high is the point in 3D space. Okay, so let's give some example of real value function of two variable. Okay, so for example, we can take fxy equals to x squared plus 3y squared. Okay, can you check that whether you produce a number on the right hand side or not? Do you produce a number? You take a number square and then add with 3 times another number square. You still get a number. Okay, so this is the real. But your input is 2 number. Okay, r squared to r. Take 2 number input, I give you 1 output. Okay, 1 output. So for example, another example you can give is, for example, 2x square root y. Okay. Okay, so so there's some terminology here. Okay, we will say that we will call the domain of x, the domain of a function, the set D. Okay, we'll call the domain of a function set D. Okay. So for example, let's look at these two examples again. So what's the domain of f here? Okay. So when we didn't specify the domain, okay, we will take if we don't specify domain, we will take D to be the what we call the natural domain. Okay, what do we mean by natural domain? Okay, if I say this domain is natural, then it must be natural. Okay, so what's the natural domain? So meaning these are all the points, okay, meaning that D is the set of all xy in the plane, okay, such that the function, such that f is well defined, is defined. Okay. Okay, so for example, where does square root x define? Naturally. Can square root x takes in value negative or not? Cannot, right? Okay, so what's the number it can take? 0 and then positive. So the natural domain of square root x is from 0 until infinity. Okay, so for example, the first one, polynomial function x squared plus 3y squared. What's the natural domain here? Yes, okay, so you can literally take anything, okay, between negative infinity and infinity. How about the second one? What is the natural domain of 2x square root y? Okay, wait. So you see, so this you can take 2 input, right? Okay, so for both x and y, you can take negative infinity to infinity. Okay. How about the domain of G? What kind of value x you can take? What kind of value y you can take? X can take anything, and then y just 0 up to infinity. Okay, so this is the natural domain. Okay, and then next, very standard one. Okay, and next will be the range. Okay, what's the range? Range of functions. Okay, so these word are Seng, you have to learn this word. Make sure you know this word. Okay, so you need to know what's domain. Okay, you need to know what is range. Okay, what is the range? Range of a function is the x set of its value. Okay, set of value.
So meaning, where can my function reach? Okay, all the function that my function can reach is called range. Okay, but be careful, don't confuse with range and codomain. Okay, range is always a subset in the codomain. Okay, if the range is equal to the codomain, what happens? Sorry? It's an onto function. Okay, not necessarily one-to-one. It's an onto because you can reach to everything in the codomain. Okay, okay, now range is only the place that can F reach. Okay, if F can reach to all the elements in codomain, then the function is onto. Okay, next definition. So you will often see that I will write z equals to fxy. Okay. Then we will call x and y independent variables. And z dependent variables. Okay. Why x and y are independent? Because you can input anything you like into the function. Okay. But z is depending on what you are inputting. Okay, so that's why z is called a independent dependent variable. Okay, so for example just now, okay, we wrote fxy equals to x squared plus 3y squared. Okay, gxy equals to 2x squared y. Okay, we can really also write, for example, z equals to x squared plus 3y squared. And then we can also write w equals to 2x squared root y. Okay, so in this case here, z and w are z and w are dependent. Okay, dependent. And then x and y are independent. Okay. Okay. So you can imagine, actually you can swap, right? Actually I can swap. So for example, I can swap like x equals to w over 2 square root y. Okay. Then if x depend on what w and y inputted, then x become the dependent. Okay, and then w and y become the independent. Okay, so really depend on how you read this equation here. Okay, so this is actually, you've seen this before actually. You've seen it as y equals to x, fx equals to x. Okay, it's the same idea here. Okay, so why y equals to x and fx equals to x have the same graph? Because they are really the same thing. Okay, just a different way to writing it. If I write it in this way, okay, I will focus that this is a function. Okay, this is a function in xy. If I just write like this, z equals to s squared plus x3y squared, we see it as an algebraic object. Okay? All the points that satisfy this equation. Okay, so function here, I think it's better we put like this sometimes. It's mean define. Okay, when I put like this is called defining. Okay, I define the function. Okay, function means what? I give you an input, you give me an output. Alright, this is function. But when I write on the right hand side here, what does it mean? This is just some number that satisfy the equation. Okay, so we see it as a root of the equation. How do I see it as a root? What do I mean by root? Root meaning solve the polynomial equal to 0. So where is the equal to 0 here? Can you see? You can move z to the other side. So as long as you are the root of this polynomial, these are all my points. Okay. Yeah, so this is the way to go between function and some algebraic object. Yeah. This is what we call variety if you go higher in maths. Okay. All right. So let's do some example. Let's do some example here. Okay, let's look at this function fxy equals to square root x plus y plus 1 over x minus 1. Okay, so first of all, what is the natural domain? Okay, what's the natural domain of this function here? X can be anything except for 1. So meaning, so wait, let me write like this, easier. Natural domain have to satisfy what? Okay, so x cannot be 1. Okay, what happens if x equal to 1? The denominator is 0. Then it is undefined. What else? Huh? X plus y must be equal to minus 1. Okay, in other words, x plus y plus 1 have to be greater or equal to 0. Okay, yeah, okay, good. And then that's all. Anything else will satisfy this. Okay, can you try and graph this natural domain out or not? And try how to graph this natural domain. So this domain is a subset of what? This function is going from where to where? R squared to R. Okay, so can you graph this domain? So where's the point x plus y plus 1 greater or equal to 0? So basically, this is the line y equals to minus x minus 1. Okay, so minus x minus 1, minus x like this. Okay, so minus 1, move it down. Okay, so this is the y equals to minus x minus 1. But your point have to be greater or equal to 0. So meaning the top one or the bottom. Okay, it's the top one. Okay, so it's the top one. How to check this? You should take a point in this region and then put into the equation. See you get the inequality or not. Okay. So you check whether x plus y plus 1 is really greater or equal to 0 or not. Right. For example, we can take a point here. Let's do an experiment. So 1, 0. Okay. 1, 0 is in this region here. So is 1 plus 0 plus 1 greater or equal to 0 or not? Yes, right, because it is 2. So 2 greater or equal to 0. Okay. So this is in the region we want. Okay. And then anything else? Is that all? Natural domain. Yeah, S cannot be 1. Okay, so we need to throw away some more things. What is the thing we need to throw away? We need to throw away the whole line. Okay, we need to throw away the whole line. X equals to 1. Okay, so this is my natural domain here. Okay, so meaning if I want to put point, I can only put on the pin part here. Okay, depend on my fxy. Okay, so how do you write this? So d of f, okay, d of f is equals to all the point, okay, all the point in R2 such that x plus y plus 1 greater or equal to 0 and x cannot be 1. Okay, yeah. So if I tell you I want to evaluate the function at xy equals to 3, 2, okay, do you know what to do? You just plug in x equals to 3 and then y equals to 2. Okay, so this is kind of simple, right? 6 volt. Okay. Okay, good. Next, how about try one more. Let's see what's the natural domain. Okay, let's look at what's the natural domain. I think it's the harder part is to get the natural domain. Substitution should be just fine. So let's check together. What's this natural domain here? y square minus x had to be greater than 0. Because ln doesn't take negative value and 0. Okay. So how to draw this natural domain here? Where's the cutting point here? Y square equals to x. Okay, y square to x. So the cutting point is when y square equal to x. So x square, y equal to x square is like this, right? Okay, either up or down, depend on the sign. So y square is either left or right. Okay, but now it's y square equals to x. Y square equal to x is always positive. So that's why we go to the right side. So here is a y square equals to x. Okay, so this is this line here. So is it on the right side, left side of the curve, or the right side of the curve when y square minus x is greater than 0? Left hand side. Why? Because it's x smaller than y square. Correct. Okay, how do you see that quickly? Just find a point. Okay, again. Okay, 100, 0. Minus 100. You mean and 0. Oh, minus 100 and 0. Okay, good. So you will get 0 square minus 100, which is greater than 0. Yeah, good. Or you can try other point in this region here. Okay, good. So we cannot include this line, right? So we need to take away this line actually. Strictly greater than 0. Okay, yeah. Okay, so above this, the f won't take value here. Okay, f only take value inside the pink region here. Okay, if you substitute, for example, here, what is it? Maybe 0, 1, 0. Okay, I give something wrong. So the top guy should be 0, 1. Okay, if you put 1, 0, this function won't give you anything. Okay. Undefined. Yeah. You can try and sub. Please sub this in, see what you get. You will get nothing. So the natural domain here, okay, is all the point such that y square is greater than x. Okay. Okay, next. So let's look at this function here. fxy equals to 1/3 of square root 36 minus 9x squared minus 4y squared. What is this? Do you ever see some square root function with square inside? I bet you see this before. What's that? What's that? Almost correct. Like square root 1 plus x squared. Remember this function? Square root 1 plus x squared. What's that? Remember? Still remember? Let me write out to recall your memory. fx equals to square root 1 plus x squared. Y equals to square root 1 plus x squared. Y squared equals to 1 plus x squared. Okay, I don't want plus. I think I want minus. And then y squared plus x squared equals to 1. What is this? What is this? Circle. So the function is what? Is the what? The upper semicircle. Okay, the upper semicircle. Right. The lower one is the minus square root. Okay, so now we just add an extra y square into. What happened? Yes. Okay, so you get a sphere. Okay, you get a sphere. So you get a upper hemisphere. Okay, you get an upper hemisphere here. Yeah, you get a upper hemisphere here. Okay, so I get something like this, and then you get an upper hemisphere here. Right. So you can set this equal to, for example, z, and then try and see that it is actually a equation for a sphere. Actually, it's eclipse, not a real sphere. Okay. Yeah. So you have to find the domain of this guy. What's the domain of this guy? Seems like no answer. What's the domain? What can you take? What's the domain you can take here? Very books false, right? You just make sure the thing inside the square root is bigger or equal to 0. Okay, so the domain, so the D is all the point, okay, all the point in R2, okay, such that 36 minus 9x squared minus 4y squared is greater or equal to 0. Are you guys familiar with this notation or not? Are you guys familiar with this set notation here? Used to it? Used to. Okay. So inside the set, what do you need to tell me? You need to tell me how does the elements look like. Okay. Where does the elements belong to? Remember the Russell paradox. You cannot contain in everything. Okay, so you need to contain some set. Okay. And then you tell me what kind of point I need to pick. Okay, no? This is the set notation. Yeah. Okay. How about range? Do you know what's the range of it? X, Y go to 0. What do you mean? Range. So where can this point go? How high it can go? How low it can go? 0 and above. Okay. So first of all, the thing inside here is greater or equal to 0, right? So since 36 minus 9x squared minus 4y squared is greater or equal to 0. That means what? That means square root of this number is still greater than equal to 0. Okay. Similarly, if you multiply by 1/3, it is still greater or equal to 0. Okay. So meaning our fxy is greater or equal to 0. Okay. So does it go all the way up or not? No, right? So where is it bounded? How to show it's bounded above? How do you know that it's the highest point? Oh, okay. Yeah, correct. Everyone, do you get what he said? You get what he said? No? Okay, so let's discuss what he said here. So he said that x squared and y squared is always positive. Right? It's always positive. So if these two numbers is always positive, you are taking 36 with the difference of two positive numbers. Okay, so the radius here will keep decreasing. Okay, so where's the highest point here? So the highest point is when you don't take away anything. Okay, the highest point is the place where you don't take anything. So it is at the point where x and y is both 0. Okay, correct. Okay, so not that fxy will decrease when you take non-zero xy. Okay, you take the value of f will decrease when you take non-zero xy, and so fxy will reach maximum x and y are both 0. Okay, which is at f00, which is equal to 2. Okay, or 1/3 over times square root 36, which is 2. Okay, yeah. So you see, this is what I call a conceptual understanding of the question. You don't go and resort, I want to use differentiation, I want to use integration, or what, right? So the first thing is, do you understand this function enough or not? Do you understand this function, what the function is doing or not? Okay, before you go and resolve to those derivative integration, you want to find static point for what? Does it make sense? Okay, because you need to think why the people think about derivative, why they think about integration. Okay, at first there's no tool like that. Okay, you cannot solve question like that. Before Newton, they don't have calculus. They also use this primitive way to solve it. Okay, so this is more important than learning derivative, integration, double derivative, and so on. Okay, so those are the things to help you to solve harder questions. Okay, so if there's easy question that you cannot use simple method to solve, then you are kind of wasted. Okay, okay. So you see, this method is like non-standard, right? So I want you to answer it as using a concept. Okay. Okay, there are 3 more examples, right? I think I will just skip them. Okay, similar question. So this is actually very important example. That's why I do it. This is a very important subject. Object. Okay, object in the mathematics. Sphere or eclipse. Okay. Okay, next. Okay, next. Let's go to the next thing. So we'll talk about this. So just now we talked about this. So let's talk about level curves. Okay, so what's level curves? So the level curves of a function f of 2 variables are the curve with equation fxy equal to k. Okay, you can see that when we define this object, right? We define mathematically. Satisfy the equation fxy equals to k. K is a number. Okay, but how does this mathematical equation tells you about some geometry? Okay, how does this tell you about some geometry? Let's read. So this k is a constant. A collection of such curve is a contour plot or a contour map. Okay, so this is what we suggested just now. Maybe there's some number on the point that gives us the path. Okay, so maybe let's see. Do we have example now? I give you see some real life example first, then later we'll see what's going on with this level curve. So for example, just now, Lohao talked about maps, right? Okay, so maps is an example of this level curve. Okay, so let's, I don't want to tell you how to imagine first. Let's do example, okay, to figure out what is this level curve is. So this example, sketch the level curve of the function fxy equals to 6 minus 3x minus 3y. Okay, for the values k equals to minus 6, 0, 6, and 12. Okay, good. So, okay, so we have to, what is the level curve of the function for this value k? Meaning what? Meaning you need to solve the equation fxy equals to k. Okay, so how many k you need to solve here? 4. Okay, so you need to solve 4 of them. Again, I let you solve now. Okay, all of you try and solve this 4 equation. And then tell me what xy you need to get. Can you try minus 6, 0, 6. Okay, check out what are these level curve here. After level curve, we will take a break, okay? Let's solve it. And let's see what a 4 level curve you get. Seeing, no. The level curve for the 4 values. Huh? Right, on the spot, easy ma, calculate only. Right. Okay, so what's the first one? Huh? Find the xy that satisfy fxy equals to k. Done? Done. Okay, so what's the first level curve? Okay, tell me what you get. Tell me what you get. 4, 0, and 0, 6. How do you get these 2 points? You just substitute and then check that it equals. Okay. How about I can also take, for example, because, for example, 1 and 9/2 also works, right? Yeah. Yes, so y minus equals to 3/2x plus 6. All these point works. All these point works. How about the second one? The slope is the same, and then just the intersection change. Okay, and then okay, good. So can you see that why we call it a curve or not? You really get a curve. And what did I wrote here? So this x like a bit. Okay. So what we get is really 4 curve here. 4 curve. Okay. Curve, right? So these are line. Okay. Slanted line. Okay, with intersection. So how do you plot this line? So for example, y equals to minus 3/2x. Plot this first. This one is the easiest one. Okay, it's here. But slanted by 3/2. Okay. And then for the other one, for the other two above, you shift to the right. Okay, for the minus 3, you shift to the left. So you got these 4 lines here. Okay. But what does this 4 lines tells you? There's a number k. What does this k tells you? This k tells you the height. Okay, height of this line. So which one is taller, higher?
The leftmost one is the tallest, and then it go lower. Can you imagine? Can you imagine this object here? So the graph is the fx, y. If you plot the graph up, it's like this. Let me bring. So it's like this, something like this. Okay. Yeah. Okay. So meaning what? What are you doing? So you have a surface like this. You have a graph. Remember the graph we said last time is living in domain plus codomain. So domain here is R2. Codomain is R. So everything you need to plot in R3. Okay, we live in R3 here. Okay. And then what is level curve? Meaning you cut at each level. If you cut through this level here, what do you get? You just get a line. Yes, the hair represents the height. Remember, think about the map, the mountain. How you draw a mountain in the map? You cannot draw a mountain, right? I mean, if you want to draw it flat, what to do? You just need to tell me the height. Okay. Okay, so the level curve is like, at this level, what is the curve? At different level, what's the curve? Okay. At each level you cut through, what's the curve you get? Okay, do we always get straight line or not? No, depending on our object. Okay, let's look at next object, and then we will take a break. Okay, after this. So let's compute the level curve of this guy. So what's this? Okay, so we have 4 of them here. Okay, we look at 4 height. Okay, look at the level curve as 4 height. So equals 0, equals to 1, equals to 2, equals to 3. Okay. So what does this represent here? So what does all this curve here represent? Circle with different radius. Okay, good. So the first one, what's the radius you get? 3. Okay, good. The second one, square root 8. Okay, good. Third one, square root 5. Correct. And then the fourth one, I think here it should be a minus, right? Oh, I should really put like this, it's better to see. And then x squared plus 1 equals to 0. Okay, so you can see that this circle is like shrinking from 3, square root 8, square root 5, and then to a point. To a point, really to a point. What is the number that square and add together you get 0? What are the number when you square them and then add them you get 0? Just 0. Because you want to get positive number adding together to get 0. Okay, so you can see that the radius shrinking, but the height decrease or increase? Increase or decrease? From 0 to 3. Increasing. Okay, so you should think that this circle, the outer circle is at the lower level, and then you bring each circle up. Kind of like a tower. So what do you get? So you have a lower circle, higher circle. Horn. Actually, this is kind of smooth, so you will get a sphere, hemisphere here. Okay, you get a hemisphere. Hemisphere. Okay, you get a hemisphere. Okay. You'll get hemisphere. Hemisphere also 1 point at the top. Okay. But the way that the circle increases is different. If you have cone, the circle will increase like linearly. But this one is like in a square root sense. Okay, in a square root sense. Okay, so this is the sphere. Okay, so in this class, it's very important. It's a very important skill that you know how to cut the object into
pieces. Okay, you should cut your object into pieces. How to build a sphere? Okay, how to build a sphere? Asking how to build a sphere? 啊，我突然了。How to build a sphere? 啊 ，How to build a sphere? How to build a sphere? How to build a sphere? How to build a sphere? Circle. Okay, you need a circle, not just line. Okay, you need circle to build out the sphere. How to build a line? Yes, a lot of points, infinitely many points. Okay, you use a lot of points. Okay, maybe I give you a early class on this one. Okay, so 0 dimensional, you got what? You got a point. 1 dimensional, what do you do? Line. What is line? You put infinitely many points together. Okay, to form a line. Okay. How about 2 dimensional? How to form a plane? Okay, you put a lot of line together. This is very important for you. Later you will do vector calculus. You need to split your surface into these things. Okay. How about 3 dimensional? How to build a box? Okay, you need a lot of surfaces or plane. Okay, you need a lot of plane. Okay, how to do 4D? Okay, I also don't know how to draw them out already. Okay, 4 dimensional. You need a lot of cube. And then go to higher and higher dimension. Okay, let's take a break until 5:20. What do you mean by NT derivative? Got. Yeah, it's a higher version. That one is like week 15 and 14, 15.
兴奋诶！
为什么很兴奋？
难诶，
哪里难？
全部都难。
难就对了。
How do you view P？因为 there's define find concept， 你就会翻去。Yeah. Computational order.
没意思啊，这里。伤心啊，这里。
笑有点白菜。
在唱。那个白色。是呀，出去有不出来，然后只可以跟你玩啊。
玩吗？
有啊，不行玩呗。
可以。玩什么？
很累耶。
哎，就是你天天回家。
天天回家。
哦，所以你们是同学
很熟呢。
谁呀？
有还想比较。
买了那个。
高级可爱，就无聊。
无聊死了，刚刚送我2.5秒。
按的话知道
本来也是
才知道一半嘛。那个里面啊，哦，我看那个，我没有看那个。要看动漫，那个每次。人家拉家那个漫画的拉就漫画有出色我没有。动漫还没有。我刚刚看有点死了，然后那个肚子里下一个死了，大夜市，在一个那个
你怎么手机来的啊？
那个上面讲在一起，
你怎么说还要啊？
剪掉，因为我知道就出来。解释错，是，我还是每个拜五去，
你还没开始啊？
我还没有开始，玩动漫，
我也还没开始。
啊。阳光海滩，我都忘了要阳光海滩，变得大。哎呦，太西迪了，西迪啊，是我所在，我是在山中的，我在就西迪的那个苗本，我在山中，那我们团到已经接，这也是港风。然后我在录啊，他跳进上车，学校都会有啊。
有没有看吗？屁股吧。
你都看到。这我们可以今天玩的。Bro， 你为什么在这边要我？
哎，看这个，那个其实这个，
对，那个都不会，但是那个会管，他们大家决定为什么要？哇，
然后这什么意思呢？你怎么知道啊？
他抖音，手不知道。
我做那时候还是设计师，那时候还是懂他那个数学那个，就是要数学的吗？还是什么？
不用 complex number。
对对。
哦，对不起，对 number， 对，还有
连着。
你见面吗？
我是你爸。
哦，然后我好猜，你们两个一起玩烂梗，你们两个。他们的冷笑话真的是像这个照片，
都没有吃吗？
值。如果你觉得它不值的话，你就加2个 C。
那太没有。
你们那个杯子，你们就是那个放杯子，然后这样子，就是那个杯子啊，然后
2个人。
2个人。
有那是
而且够打，要玩一下，可以玩，那个吃饭才可以玩。
哎，那个
吃饭那个。
对。下次再玩。
Okay. Let's start again. Start again. Okay. So next is this one. Okay, matching contour map again. So this contour map, right, give you the level curve, okay, but it doesn't give you the height. Okay, it doesn't give you the height. So you can study together with the right hand side.
to tell you what's the height. But the contour map will tell you the level curve. Okay, see that the first level curve here is like a circle and then half circle actually. It's like a triangle. Okay. And then this one is like a spider. But it's not actually spider because no space to draw. Actually, it's a big circle, because no space to draw. Okay, and then so you get this kind of object here. How you see this? So at each level you should cut it. Okay, so if you cut it across it, you will get a circle, get a circle. Okay, but here what happened? This one goes downward. Okay, so you cut from the bottom. So actually this circle here is lower than the upper circle here. So the upper circle here is at higher K. This circle is at a lower K. Okay. Yeah. The example is in the lecture note. Okay. Yeah. So remember what's level curve? So you take your graph and then you slice it at each level. And then the K will represent the height. Okay, you slice. Okay, you slice. So we can go to higher space. Function of 3 or more variables. Meaning what? This is like R, F from R3 to R. Okay. So where does this graph live in? R3 plus R, which is R4. Okay, we cannot draw R4. But if you can draw it one day, please tell me. If you can draw R4 one day, please tell me. Okay. Yeah. Video editor. Okay. Sure. Yeah. Hey, why? This is the example I give to my student. So you are like, when you're playing YouTube, actually you are dealing with R4. You know why? So R3 is inside the screen R2. So in the computer screen is R2, right? But you can see R3 word inside. So where's the fourth dimension? The fourth dimension is the time. It's the time. You can even control the time. You can stop the time. You can fast forward. You can move backward. So you are controlling R4 every day. Okay, yeah. Okay. Okay or not? Okay. So you see R4 inside R2. Yeah. Seeing R4 inside R2. Okay. So yeah. So this is 3-dimensional function. Okay, give you a R value. Okay, if higher dimensional, you can see f of Rn into R. Okay, but the highest dimension we get in this course is 3. So in abstract maths, you will deal with Rn, arbitrary n. Okay, so let's say if in R2 to R, right, when we slice in each level, we get curve. If we go 1-dimensional higher, what do we get if I slice my graph? I grow from a curve, a line, go up 1 dimension, I get a surface. Okay, so we will get a level surface. Okay, if I try to slice my function of 3 variables here. Okay, so let's see what's the level surfaces of this function here. Okay, what's the level surface of this function? So this function is from where to where? So whenever you see a function, right, you should ask yourself, this function is from what space to what space? Okay, so this function takes in how many values here? 3. Okay, so this is going from R3 to R. Okay, is it true or not? Is it all R3? Can you take every R3 here or not? Okay, so this actually is a subset of the R3. Okay, so this subset is what we call the natural domain. Okay, what's the natural domain? These are all the points that has to be what? Has to satisfy what kind of property? Is
greater or equal to 0 because of the square root. Okay, so you want to see the the level surface here. Okay, what k we need to set? What k we need to set here? Can I set k to be -1 or not? Huh? Cannot, right? Why? Yes, because square root you cannot get negative number. Okay, so that means -1 is not in the range of f. Okay, f cannot give you negative number. So you need to fix k in the range of f. Okay, you need to fix k in the range of f. So for example, so if I want to see the level surface, I need to solve this equation here. This equation is just k equals to s squared plus y squared plus z squared. And then this is actually a sphere. Okay, sphere with radius k. Okay. If just now we have x squared plus y squared equals to some radius square, right? That one is circle. So if I add another variable square, I get sphere. If I add another variable, I get higher dimensional sphere. I can keep adding variable square to get higher and higher dimensional sphere. Okay. So what do I get here? Level surface actually is a bunch of different sphere. Okay, a bunch of different sphere. Yeah. So this is the level surface, right? So meaning if I cut the original function here, okay, if I cut this function here, what I get is sphere. So what's the origin? Like what's the original graph? Looks like. Yeah, you can try and imagine. Okay. We can only plot level surface because this is the higher dimension, highest dimension we can draw, R3. Okay. Yeah. What's the thing when you cut? It's look like this. Oh, height represent here. Yeah. What does the height represent here? Okay. I don't know. You can try think about, and then you can let me know. Okay. Just now we represent k as a height, right? But see this sphere is like enclosing each other. So what does it mean? Right? So the sphere is like enclosing each other. So k can be anything greater or equal to 0. So you get all these level surface. So what's the original thing? Okay. Just now we use circle to build sphere. And then we use line to build plane. How about this one? Huh? Well, we have a lot of sphere. What do we build? What do we get? Sphere skin. Okay. Okay. How to cut? I also don't know. How to cut a 4-dimensional thing? How to cut? Where's that dimension? Where's the 4th dimension? The 4th dimension, right? I need a 4th dimension to draw 4-dimensional thing. Here only 3 dimensions. Where's the 4th axis? Where is the 4th axis? Okay. Yeah. Think about it. Think about it. Think about it. Hey, have you guys watched a movie? Interstellar. Yeah, 星际 something. Interstellar. Ever watch or not? You can go try and watch it. Interstellar. Interstellar talk about fifth. Yeah, time we know that it's 4th dimension because it's Einstein stuff, Einstein theory. But that guy traveled through 5th dimension. Is it? Yeah. Yeah, in the last scene. Okay. So there's only one force that permeate that dimension, is the gravity. Yeah, they predict that gravity can go to different dimension. And then that's why, if you watch the movie, he control the book inside his daughter room.
Oh.
And then the room, he cannot see his father, but the book drop using gravity. That's the idea. The science director for that movie is the Nobel Prize. Nobel laureate. What's the name? I forgot. Yeah, it's the Nobel Prize for doing stuff about gravitational wave. That's what they predict. So they make it into a movie. Okay. Okay. Yeah. Okay. Next, we will go to limit. Let's go into the idea of limit. What do you know about limit? Can you tell me about? What have you learned about limit? So I want to talk about. Let's talk about limit. Limit on limit of. Seeing this one very important concept. I tell the other class the concept is more important than what is the technical thing is. Because once you grab the concept, you'll easily understand what we want to do next. Okay. So what did you learn about limit of a real value function? Let's say on one variable. Okay. Let's say function from R to R. Okay. What does the limit of fx equals to L mean? Any idea? Any idea? Okay, good. So let's just draw some point, right? Then we have A here. A is a fixed point. L is also a fixed point. So here's the point. Okay. So when my x get closer and closer and closer, okay, when my x get closer and closer, anywhere, okay, you can approach from the right. If you approach from the right, it's the x plus. If you approach from the left, it's called x minus. But in pure max, you can go anywhere like this, jump here, jump there. As long as it's close to A, it's fine. Okay. When you get closer to x, what happens to your y? Okay, your y have to be no matter what direction you go. Okay, you jump here, jump there, jump here, jump there, right? When you x get closer to y, A, your value will get closer to x. L, sorry, L. Okay, get closer to L. Okay, so how do we describe this? Okay, so we give an epsilon delta definition here. So meaning what? Okay, meaning what is epsilon delta? So meaning if I give you an epsilon, okay, so this epsilon, what does this epsilon do? So this epsilon will tell you something around L. Okay, let me make it bigger. It will tell you something around L. Okay, so epsilon is here. Either from the top or from the bottom. Okay, so meaning what? Meaning it could be the case that your function is approached from the top. That's okay. Within this epsilon, okay, within epsilon, okay, can I find, very important, can I find, okay, a delta, okay, delta, such that the fx inside here is close to this L here. Okay. Make sense? Okay. So for every epsilon, there exists a delta, okay, delta greater than 0, such that if my point is in the domain and it is within okay, it is within delta distance, okay, then there's this a point fx minus L is less than epsilon. Okay. So what happened? Okay, what happened if I cannot find such epsilon? Okay, so for example, I scrap this away. So let's say if my function do like this, pass by this point. Can this point be a limit of my function or not? Okay, if I squeeze my epsilon to here, if I squeeze my epsilon to here, okay, if I squeeze my epsilon to, can I make it smaller? Is it true that for every delta you can find point that is close to this point? Can you find the pinpoint anymore? Cannot, right? Okay, so this has to be true for all epsilon. Okay, so you won't reach, you won't reach this point. Okay, if you cannot satisfy this epsilon delta definition. Okay, yeah. So if it is a limit point, okay, if it is a limit point, that means no matter how small, how small you put this epsilon, surely there exists a delta that you can find the point that's close to that. So this is the epsilon delta definition. Okay, the first time I saw this, I was also very like, what's this? Epsilon delta, what is this? For every I that exists, what's this? I think I only start to appreciate this after 2-3 years. At that time, our tutor is not good, our lecturers are not good. But afterwards, they adjust the course. And that course is called 1115. It's very hard. And then that time the tutor is not good, lecturers are not good. Just talk quickly. And then after that they change. They have a power mentor section during the tutorial. They have like 1 hour is power mentor, the other hour, 2 hours of tutorial, the other hour is a tutor. I become tutor before, but I never be a power mentor. So they describe this concept by drawing. When I first saw it, I just see epsilon delta. I don't know what is it. Okay. Yeah, so very important. This concept. Okay, about limits. Okay, so we want to throw this into a 2-dimensional. So what do we do? Okay, so we increase the dimension of this domain. Okay, instead of going left and right, we expand the dimension here into 2D. Okay, so we add another dimension here. So we add another dimension here. So now we want to talk about R2 to R. Okay, so meaning you not only can go to this point by doing left and right, you can go in different direction here. So this different direction here is what we call a ball. Okay, we can approach air within a ball. Okay, we can make this ball smaller and smaller and smaller and smaller. Okay, and look around that point. Okay, okay. So I motivate you this definition here. So what is the limit of a function of 2 variables? So let f be a function with a domain D that includes points that arbitrarily close to AB. Okay, so because we increase the domain of our increase the dimension of our domain, right? So into 2, so we have coordinates of 2. Okay, 2 variables here. And then we say that fxy is L, whereas xy approaching the point AB, we will write like this. Okay. So instead of 1 variable, you have 2 variables now. Okay. And then this is the similar epsilon delta definition. So for every epsilon, okay, you need to find a delta, okay, such that whenever your xy is close within, okay, within the delta ball or delta ball here, you still can find a function value of function fxy that is epsilon close to L. Okay. If you cannot find that, this means your function passed by the point. Okay. So you must be able to find such point. So it is like you want to have some continuous, right? So it's like, how should you imagine this thing? So it's like, let me draw. So you have an L here. You have an L here, right? Okay. And then you want to check, actually this is a 3D point, right? Let's call it the ABL. ABL, JBL, ABL. Okay. So here is the AB. Okay, here's the top. So what do you do? Okay, what do you do? So for every epsilon, right? So for every epsilon, okay, you need to find around this ball that's point near to this guy. Okay. And then you try to reduce this epsilon again. Okay, is there any point that's epsilon close to this point or not? Okay, so you are like filling in, keep filling in until you join with that point. When the epsilon get really close to 0, okay, you are like filling in all the space until you reach the point, the limit point. Okay, now imagine. Imagine. Okay, yeah, okay. Okay, yeah. So note that there's a technicality here. You see, y strictly greater than 0? Y strictly greater than 0. There's a technical point here. Y strictly greater than 0. Equal to 0, what does it mean? Yes, no difference. No difference between who? Between the point AB and the nearby point. So meaning you reach the limit point, okay, using AB. Okay, so here we don't demand that we have this point in my function. Okay. Makes sense or not? We don't, for the definition of limit, we don't demand that the function will reach that point. Okay. Any example? Let me see. Any example? So, for example, this example here. Okay, this is a very classic example. So, let's look at this graph here. This and this. Okay, so let's call this a 1 and then 1 here. So, you see, so I want to ask you, what's the limit of this function at 1? What's the limit of this function at 1? 1 or 2? Why? No matter how small I check around this y value, I can find x value that is delta close to it. Okay. Here I cannot write. No one's near this point. Okay. So limit means I just want to check from the left or right what happened. From the left to right, what happened to the value of f. Okay. For one variable is left or right. For two variable is a direction of ball. Okay, coming from 360. If 3-dimensional, you come in direction of sphere. Okay, higher dimensional ball. Okay, so for limit, we don't care about, so this is f. So we don't care about the point at 1. Okay, so this is fx. Okay, so we don't care about the exact value of f at the limit point. Okay. Let's say if I have this point at 1, what happens? This means that my function is continuous. Okay, so meaning my function, if my function achieve my limit, then my function is continuous. Okay, yeah. Okay, good. Okay, let's continue with limit first, then we'll go continuity. So for example, okay, just now I did tell you already, FAB need not be defined. Okay, if you want to look at function FAB. If the limit exists, fxy must approach the same limit no matter which path takes to approach AB. Okay, this point is very important. Okay, so if you want to show something, the limit doesn't exist, you just need to pick two paths. Okay, that give you different limits. Okay, because they have to come in with the same limit, right? So you just need to find two paths that has different limit to show that limit doesn't exist. Okay, let's look at this example here. Given a function fxy, it is known that xy approach 0, 0 along the x-axis. Okay, let's draw this out. Okay. So whenever you read these question, right, try to picture it. Okay, try to picture it. So we have this picture here. Okay, so here is fx. 0, 0. It is known that xy approach 0, 0. Where is 0, 0? So 0, 0 is at the origin here. Okay, along the x-axis. Where is x-axis? So x-axis is here. Okay, it doesn't say whether right or left. So you can assume anyway. Okay, so you will approach the point 2 here. fxy approach 2. It is also known that xy approach 0, 0 along y-axis. Okay, you also approach 2. Okay, the question is, can we conclude that the limit of this function going to 0, 0 is 2? Can you do that or not? I just only know the limit approaching from 2 directions. Can you deduce for all directions? Cannot. 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 Maybe can. Maybe can. Cannot. Can. Okay, let's look at example and then we will come back to this. Okay, so try and guess the limit based on this calculation. So let's look at this function, sine x squared plus y squared over x squared plus y squared. Okay, we check limit to the 0, 0 point. Okay, so what do? We check around this point here. Okay, so 0, 0 is here. Okay, and then you get 0, 0.2, 0, 0.5, 0, 1.5, and then so on. Do you guys know how to read this table here? Okay, so you combine this coordinate. Okay. So the coordinate is like the intersection of the row and the column. Okay. And then all these, what are these value here? These are the fxy value. Okay. Okay, no? Can follow? Okay. So what is going on here? What is going on here? If you go from the x-axis from the right, what happened? The number increase. So okay, let me draw something maybe easier to see. So here, can everyone see now? Okay, here is the x-axis. Okay, and then forward is the y-axis. Okay. Wait, y go to the different direction, right? So increasing downward. Okay, you see, y is increasing downward. I think wrong, right? Because here is for x, here is for y. So let me swap. Okay, let me swap. But doesn't matter, okay? Not too important, but make it right. Okay, so what happens if I go from y for the right? The number increase to 1, okay? From the left, increase to 1, okay? From the x-axis, downward increase to 1, okay? Upward increase to 1. How about the other direction? I can pick like this, turn away, turn around, and then come. What happened? what happened to the limit? See what happened to the limit? The limit changed along the path. Okay, but when I get really close to 0, 0, what happened? The limit still approaching 1. Okay, so this means that no matter what direction you get, okay, to approach 0, the f value approaching 1. Okay, so this limit here is 1. Yeah. Okay. How about next example here? Next example here. Okay, so I got x going downward again. Okay. X going downward. And then got y going to the right. This x. Okay. This function we are looking at x squared minus y squared plus x squared plus y squared. Okay. And do you know why we are interested at the point origin? We don't simply pick point 1. At this point, what happened to the function? Don't know define or not. 0 over 0. Okay. 0 over 0. Okay. And then, so what happened to this? If we go along x, right, you get minus 1. Okay. If you go along x, you go along y, you get minus 1. You go along x, you get 1. Okay. So it's 1 or minus 1. And if you go different way, if you go diagonally, what happened? It is 0. You go different direction, it's like 1, 0 also have, 1 also have, minus 1 also have. Okay. So how should we imagine this? So how should we imagine this graph here? Going from the right side, the graph is like sink down, right? Okay. Going from the right side is also sink down. Okay, but going from the top and the bottom, the graph is like grow up. Okay. Yeah. Should we draw this? How do we draw this? So, so let's draw the 0, 0 line first. Okay, and then sink down. So how to sink down? So maybe use a darker color. Okay, darker color, maybe use first. You imagine this one is sinking down, and then how to draw it grow up. So maybe like this. Still hard to see. Okay, let me try this one. So we want to sink down, right? Is it easier like this? Can you imagine what I'm trying to do? Let me think. Okay, let me think. So let me think. Okay. So like this. Okay, I think this one use darker color. And then so you grow up. Wait, maybe I use the same color first. Then, okay, so how should you look at this? So you should think that this one sink down and then this one move up. Okay, so let me try. Oh, I forgot to take attendance, right? Okay, later I'll take. So I use attendance sheet bigger. So it's like So this is the side that going up, and then the other side. Yeah. But without the middle point. Without a middle point. I throw away the middle point. Okay. Okay. Yeah, throw away the middle point. Actually, you can plot this online as well. You can plot this online. You need to throw away the middle point so that you can see. Okay. Yeah. Top and bottom is up, and then right and left is down. And then you need to imagine you throw away this point so that the side will go down and the other side will stay up. One side is 1, the other two sides is -1. Okay. Okay. Yeah. So the limit doesn't exist because if you have different path giving you different number, it doesn't exist. So similar to this, you only know 2 paths. Okay. Do you know other path or not? Not really. Okay, not really. Okay. Okay, any question before we leave? So fast. Okay, I think full yeah.
Line between y-axis and x-axis.
Cannot. What do you mean? Cannot. You mean line like this? Cannot, right? There's no information on that. Yeah, no information on that. Although, maybe you think that x and y axis is the basis of my R2, right? But I never tell you what happened to your value of f at different point. Yeah, because this f, is it a linear transformation? Maybe not. If it is a linear transformation, what happened? You can try. Maybe if it is linear transformation, you can get something out of the basis. But most probably it's not linear transformation. Because we look at x squared, y squared, x cube, y cube, these things are no longer linear. You can think about it. If it is linear, is it enough to know about x-axis and y-axis or not? If my function is linear. Or can you come up with a counterexample when f is linear, but the information on x and y is not enough? Okay, always start with an counterexample. Counterexample is relatively easier because when you construct counterexample, will tell you whether something is true or not. Why is it true? Why I cannot construct one? Because it's true. I mean, yeah. Okay. Yeah. So one mathematician's mindset is that if I don't believe, I try whether there's a counterexample first. Okay. Yeah. Usually, most of the time, counterexample is easier to find. Okay. Okay. Any question? Other question? I want to go already. Okay. See you on Thursday. Okay, Thursday. Yeah.
在都上面 pro，
好。
一个可不换。